and welcome to a video about my new method for tuning IMU. So we'll start with a blank slate. Currently, all of the IMU values have been set to the defaults. I am using beta 23 firmware, and I have tuned this IMU before, but I'm not going to be directly referencing those values in this process. I'll be showing how to do it from scratch. So here we have some correct inputs, IMU type internal. You can use the wizard to detect your IMU if you need to detect it, but usually it's just here. Doesn't have one. Set this at 832 for the LFOC 3.1, as well as the 250R and other Tronic products would all be about the same sample rate. For the low pass filter on unicycle applications, I recommend 10, 10, and 50 as a starting point. Never touch this one. I always use Fusion because it has an extremely rapid response. It's much faster to calculate the correct position, so in real time you can get more realistic angular values than any of the others. 1 is a terrible value. 0, 2, 0, 1 is sometimes okay. Some circumstances 0, 0, 1, but I'll just stick with 2 in this case. I've had good luck with setting this around 4, this one around 5. Before you even tune your IMU, don't even touch these values. Okay, you have to figure out which way is front, back, left, right, and forward. You will need to determine your IMU roll, pitch, and yaw according to a 90-degree increment. What that means is you want to round it to the nearest 90-degree value that makes sense. Let's say your controller is on top, but rotated 180 degrees, so it thinks pitch forward is pitch reverse. What we can do here is that we can rotate the yaw 180 degrees. In my case, my controller isn't mounted dead level in the compartment, so I offset this by 0.6 degrees. So these are aligned to true differences in the reality of the controller. So let's say that your controller wasn't aligned straight, we could do 179 degrees. But in general, we want to keep within a few degrees of a 90-degree increment, and we want to keep the 90-degree increment concept because it will allow us to tune the rest of these very easily. Now the next step is that you have to turn on the unicycle with all these at zeros. So it's not going to be perfect, right? But it will at least allow you to determine, does this thing really balance? Is it reacting to pitch correctly? Are the roll and pitch axes flipped? In that case, you might need to add some other 90-degree increments in here to get this to rotate to where you want it to be. What we do next is that we can write this app configuration. So note that this is a fresh firmware. There's no packages installed. Nothing's going to start up. It should just be writing the app, specifically the IMU setup that I just dropped in here. So we're going to write app configuration. And you can see that this guy repopulates, things get centered out. And we can kind of look at what's happening. And you can see that the yaw is drifting, and my objective here will be to make that yaw not drift. We can also see that the pitch is riding quite a bit above 0, and the roll just happens to be very close in the default configuration. So we're going to move to the other tabs and evaluate what's actually happening with the IMU. Under the Excel tab, we can see the one up here is Excel Z. It's riding a little high. The others, they look pretty close, but the gyro is way out of whack. We can see that the y-axis here is not only noisier than the others, but it is also way up here. So this is just like a technician assessment of what's going on with the system. You need to be able to understand these graphs a little bit. So the objective is to have this here centered on 0. These others should be centered on 0. So currently my unicycle and controller are all mounted together, and it's in the level position. So what we're going to do is we're going to open up the Lisp scripting here. We're going to open my script. Here we can upload the script. And we have the outputs. Now we can see the values are going pretty well. Looks like we have it pretty flat and pretty level. So let's power cycle the system, get everything back to zeros. Alright, I consider this to be a okay result. To be honest, I would like to see the yaw drifting a little less. But let's check out the other graphs, see how they're going. That looks pretty on there. And that looks pretty good. I don't know if we're going to get much better with that much gyro Y noise. Let's look at the peaks here, but we can see a bit of an asymmetry. See the over time, see one is way up here, -1 is down here. So let's try and fix that gyro Y. And what we can do is actually run the script again. I'm gonna run it one more time and see what the differences are. So what we get when we run the script after we input values is actually the difference from the present value. It has to be the opposite of this value when you run it again. So that means we need to add 6 to the present value. RPY, everything looks okay. That's a pretty slow rate of change. These are about around 0. Yeah, we look